Hello everyone, myself Dr. Ramgopal, working as Associate Professor in Mathematics, Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. I welcome you all today's session on testing of hypothesis concerning variances. Let us recall the previous sessions. In the last session, we have discussed the testing of hypothesis concerning two means for small samples. In test of hypothesis concerning two mean small samples, we apply t-distribution. So the test is also called t-test, and also we discussed some problems on the same. Coming to the today's presentation, today I would like to introduce the f-test, which is used to test the hypothesis concerning variances, and also I solved two problems on f-test. Now coming to the test of hypothesis concerning variances, to test for the equality of population variances, we apply f-test. Here we consider two populations, population 1 and population 2. From population 1, let us draw a sample of size n1 and draw another sample from population 2 of size n2. And let the small s1 square be the variance of first sample and small s2 square be the variance of second sample. Now here in f-test, we test whether these two populations are having the same variances or not. For example, sigma 1 square is the variance of population 1 and sigma 2 square is the variance of population 2. To test whether these two populations are same, that means sigma 1 square is equal to sigma 2 square, first we calculate the estimates for population variances, and those are given by capital S1 square and capital S2 square. So let capital S1 square and capital S2 square be the estimates for population variances given by S1 square is n1 into S1 square, small s1 square by n1 minus 1, and similarly S2 square is n2, the size of the sample 2, multiplied by variance of sample 2 divided by n2 minus 1. And here this n1 minus 1 and n2 minus 1, which are denoted by nu1 and nu2, are the degrees of freedom of these two estimates. So to test whether the two populations are having the same variances or not, first we have to calculate these capital S1 square and capital S2 square. And here these capital S1 square and capital S2 squares can be calculated using this formula also. Sigma xi minus x bar whole square by n1 minus 1 and sigma yi minus y bar whole square by n2 minus 1. That means if the data is given, we can calculate the variance of both samples S1 square and S2 square, and we know that the variance of a sample small s square is given by sigma xi minus x bar whole square by n1 n minus 1. For first sample it is n1 minus 1, for second sample it is n2 minus 1. And by using this we can simply replace the terms using sigma xi minus x bar whole square for first sample and sigma yi minus y bar whole square for second sample. And these are called the sum of the squares of deviations with the mean. So sometimes in the problem, the sum of the squares of deviations about the mean will be given in the problem itself for both samples. So this xi are the individual elements of sample 1, x bar the mean of sample 1, yi are the elements of sample 2, y bar is the mean of sample 2. And this indicates the sigma is for summation, sum of the squares of deviations of the elements with the mean. So if those values are given directly, we can substitute here and we can use this formula, S1 square and S2 square. Now in f-test, we test the null hypothesis that both population variances are equal against the alternative hypothesis that both population variances are not equal. So again here there is one and only one alternative hypothesis. Both the population variances are not equal. And we use the f-test, and the test statistic f follows the f distribution with nu1, nu2 degrees of freedom. So to find the tabular value, here we calculate f alpha for nu1, nu2 degrees of freedom. And also we know from the properties of f distribution, the value of f depends not only on u1 and u2 but also in the order they have given. are stated. So we have to consider this order also. And coming to the test of hypothesis concerning variances, these are the steps involved in testing of hypothesis. So the null hypothesis H0 is both the population variances are same. Sigma 1 square equal to sigma 2 square. Against the alternative hypothesis, the population variances are not the same. And level of significance will be given in the problem either 5% or 1%. And the critical region, here we write the condition to reject the null hypothesis. Simply the region in which we reject the null hypothesis is called critical region. And in F test, if our calculated value is greater than that of tabular value, simply reject the null hypothesis. That means accept alternative hypothesis. For example, if our calculated value is less than that of tabular value, then we accept the null hypothesis. And calculation part, the test statistic is given by F calculated is S1 square, capital S1 square by capital S2 square. These capital S1 and S1 square and S2 square are calculated using the previous formula, capital S1 square and capital S2 square from the given sample data. And here it is customary or mandatory to consider the greatest sample variance in the numerator, greater variance in the numerator. And according to that, we consider the degrees of freedom also. For example, if S1 square is greater than S2 square, then F calculated will be S1 square by S2 square, which follows F distribution with nu1, nu2 degrees of freedom. For example, if S2 square is greater than S1 square, then the calculated value will be given by, since S2 square is the greater value, let us consider that in the numerator. So S2 square by S1 square, this follows F distribution with nu2, nu1 degrees of freedom. Because we are considering the second sample variance in the numerator, the order will change. So nu2 comes first and then nu1. And finally, take the decision by comparing the calculated value and tabular value. Let us discuss one problem. Pumpkins were grown under two experimental conditions. Two random samples of 11 and 9 pumpkins show the sample standard deviation of their weights as 0.8 and 0.5 respectively. Assuming that the weight distributions are normal, test the hypothesis that true variances are equal. Use 5% level of significance. So here, test the hypothesis that true variances are equal. True variances means these variances are regarding the population. So population variances sigma 1 square and sigma 2 square. These two are equal or not, that we need to check. And what is the given data? Two random samples of 11 and 9. So N1 is 11 and N2 is 9. And the sample standard deviations of their weights are 0.8. So small s1 is 0.8 and the small s1 is the standard deviation. It is given standard deviation. So s1 is 0.8 and s2 is 0.5. Now we can calculate s1 square using this, the variance, s2 square also here, and we can calculate capital S1 square and capital S2 square, the estimates of population variances using the known formula given in the previous slide here. N1 into S1 square by N1 minus 1 and S2 square is N2 into S2 square by N2 minus 1. So first try to understand the problem and note down the given data and what is the required one to test. So if you understand all these points, simply the test is as follows. The null hypothesis H0. Here the problem is to test the hypothesis that true variances are equal. So sigma 1 square is equal to sigma 2 square. That means both population variances are the same. And we test this null hypothesis against the alternative hypothesis sigma 1 square is not equal to sigma 2 square. That means both populations are having different variances. And level of significance, use alpha equal to 5%. So that is given in the problem itself. Alpha equal to 0.05. Critical region, the region in which we reject the null hypothesis. So reject H0 if our calculated value is greater than the tabular value f alpha. So here n1 and n2. n1 is given 11, n2 is given 9. 11 and 9. So new one, n1 minus 1 degrees of freedom, 10 degrees of freedom, and new 2, 9 minus 1, which is n2 minus 1, 9 minus 1, 8 degrees of freedom. So from the F distribution table, we need to calculate F 0.05 for new 1 is 10, new 2 is 8. And from the F distribution table, this value is 3.35. This is the tabular value. Now we need to calculate F calculated value given by capital S1 square by capital S2 square. First, capital S1 square, what is the formula for capital S1 square? N1 into small s1 square by n1 minus 1. Similarly, capital S2 square is n2 into s2 square by small n2 minus 1. And this first value is given by, after substituting, n1 is 11 into 0.8 whole square divided by 10, and here n2 is 9 into 0.5, 0.5 whole square divided by 8. So these two values after calculating will get 0.704 and 0.281. And it is very clear that S1 square is greater than S2 square. So S1 square is the greater value of these two variances. So the calculated value is given by 0.704 divided by 0.281, which results as F calculated is 2.5. So this is our calculated value and this is our tabular value. And since the calculated value is less than, so 2.5 is less than 3.35, F calculated is less than F alpha for new 1, new 2 degrees of freedom. If our calculated value is greater than that of tabular value, we can reject the null hypothesis. But here we got the result as our calculated value is less than that of tabular value. Therefore, we cannot reject the null hypothesis. That implies we have to accept the null hypothesis H0. What is that? Both populations are having the same variances. So this is the final conclusion using F test. Similarly, let us discuss one more problem. The nicotine contents in milligrams in two samples of tobacco were found to be as follows. So two samples are taken, sample A and sample B. The nicotine contents are given in milligrams. For sample A, 1, 2, 3, 4, 5 values are taken, and for sample B, 6 values are taken. Can it be accepted that two samples have come from same normal population at 5% level of significance? So if these two samples have come from same normal population, that means both the populations must be having the same variance. So here first write the given data. N1 is 5, N2 is 6, and since the data is given, we need to find first, for example, X denotes sample A values, Y denotes sample B values. First we need to calculate what is X bar, Y bar. X bar is sigma X by N, Y bar is sigma Y by N, the mean of the two samples. First X bar, 24 plus 27 plus so on 25 divided by 5, that results as 24.6, and Y bar 27 plus 30 plus so on 36 divided by 6 values are given, so divided by 6, 29. Then we need to calculate the sum of the squares of deviations about the mean. That means xi minus x bar whole square, sigma xi minus x bar whole square for first sample, sigma yi minus y bar whole square for second sample. Since the individual values are given, the data is given, we can calculate this sum of the squares of deviations of the values about the mean. In the first sample, we use x bar equal to 24.6. For the second sample, we use y bar equal to 29. So after calculating, these two values are given by 21.2 and then 108. Then we can calculate capital S1 square using the second formula given. If the deviations are given, we can use this second formula. S2 square is given by sigma yi minus y bar whole square divided by n2 minus 1. So after substituting these values, this results as 5.3 and this results as 21.6. Now coming to the actual test of hypothesis, here the null hypothesis H0, we need to test whether the two populations have come from the two samples have come from the same population or not. The two samples will be from the same population if the two populations are having the same variances. So our null hypothesis will be both the population variances are the same. And we test this null hypothesis against the alternative hypothesis. Both the sample variances are not same, they are different. And level of significance, let us use alpha equal to 0.05 as it is given in the problem also. Alpha is 0.05. Critical region, so reject H0 if F calculated is greater than F alpha nu 1 nu 2. But here, since S2 square is greater than S1 square, we have to use the formula F calculated as S2 square by S1 square. This is the general formula, but it is customary to consider the maximum value in the numerator, the greater variance in the numerator. So that's why we consider S2 square in the numerator. So here, instead of taking F alpha nu 1 nu 2, we have to test, we have to find the tabular value as F alpha nu 2 nu 1 as we are using the second sample in the numerator. So for 5% level of significance and nu 1 is 5 minus 1, 4 degrees of freedom, nu 2 is 6 minus 1, 5 degrees of freedom. F 0.05 for nu 2 comes first, nu 1 second, 5 comma 4. So this value is given by, from F distribution table, you can calculate this as 6.26. You can find out this from F distribution table. Now let us substitute the obtained values of capital S2 square and capital S1 square, 5.3 and 21.6. We have to consider the maximum value in the numerator. So that's why S2 square will be, S2 square is 21.6. So let us substitute 21.6 in the numerator divided by 5.3 in the denominator, which results is 4.075. And now we have to compare this calculated value with this tabular value. Since 4.075 is less than 6.26, our F calculated is less than F alpha. If the calculated value is greater than F alpha, we reject the null hypothesis. But again here we got the calculated value is less than that of tabular value. Therefore, we cannot reject the null hypothesis. Hence, we accept the null hypothesis H0 that both populations are having the same variance. That implies, what is our final conclusion? That implies the two samples have come from same population. So this is the final conclusion that we can take by applying this F test. And coming to summary of today's presentation. In today's presentation, we have discussed the test of hypothesis concerning variances. That means we test whether the two population variances are the same or not. In this, we apply F distribution, which is called F test. And we have discussed some problems also. In the next session, we will discuss the test of hypothesis concerning several proportions, in which we apply chi-square test. Thank you.